Hi, I'm Nathan with Holston Gases. During this training module, we're going to talk about the flux core arc welding process. We're going to talk about what the flux core arc welding process is. We're going to talk about how to identify the difference in an all-position flux core wire and an in-position flux core wire. And we're going to talk about a few mistakes that are commonly made when using a flux core arc welding process. So the flux core arc welding process is a welding process using an electric arc between a continuously fed filler metal electrode and the weld pool. The process is used with shielding gas from a flux contained within the tubular electrode with or without additional shielding from an externally supplied gas and without the application of pressure. Today we're going to talk about the flux core arc welding process that uses a shielding gas. So as you can see in this schematic, a flux core electrode is a composite tubular filler metal consisting of a metal sheath and a core of various powdered materials producing an extensive slag cover on the face of a weld bead. So some of the ingredients that are inside of a flux core wire inside of that tube are the deoxidizers, alloying elements, arc stabilizers, slag formers, gas formers, and fluxing agents. And one of the advantages of a flux core wire is these ingredients can be easily changed during the manufacturing process. So this ingredients that's added will also impact whether or not this wire can be used in position or out of position. So if we look here at this AWS classification, we'll see that the E represents that this is an electrode, meaning current is traveling through it. 7 is the tensile strength, so 7 times 10 gives us 70,000 pounds per square inch of tensile strength. The third designator tells us whether or not this is an in position or out of position wire. So here you can see that it's an E71T-1. This one tells us that this wire can be used in all positions. If it was a 0, it could only be used in the flat and horizontal position. So just because you're using an all-position wire doesn't necessarily mean that an all-position wire is best if you're only welding in the flat and horizontal positions. An all-position wire has a very fast freezing slag system, and so if you're welding over some mill scale or rust, then using an all-position wire may allow porosity to get trapped or gas to get trapped, causing the porosity in the weld bead. So if you used a flat and horizontal wire, it would have a slower freezing slag system, and this would allow some of those gas pockets to escape rather than getting solidified underneath the slag system. So just keep that in mind when you're using your all-position wires in position. So now let's look back at that AWS classification that we were looking at a little bit earlier. So we talked about the E and the 7 and the 1, and now when you talk about the T stands for tubular. This tells us that this is a tubular wire, and once we see that T, we know that we've got a flux core wire on our hands. Then after the dash there's a 1. This indicates the type of shielding that this flux core wire will use. So if it's a 1, a 2, or a 5, this indicates that this wire uses an external shielding gas. If it's a 3, 4, 6, 7, 8, or 11, this indicates use without gas. And if this is the case, it's important to check the data sheet that comes with the wire to see what polarity that you're going to use to run that wire. If it's typically if it's a gasless flux core wire, it's going to require the polarity to be set at DC electrode negative. With a flux core wire that's using a gas, typically we use DC electrode positive. But it's always best to check the data sheet to find out that you use the right current polarity for the wire that you're using. And then lastly is where the X is, that could be either a C or an M. The C means that you can use 100% CO2, and the M means that you could use 75 to 80% argon balanced CO2. And in some cases you can use 100% CO2 or the mixed gas, 75 argon, 25% CO2. Most commonly 100% CO2 is used, or 75% argon, 25% CO2. But again, this is all found on the data sheet that comes with the box of wire or can be pulled off of line. So let's take a real quick look at a data sheet that's common to a flux core wire that you can get printed, that you can get downloaded from the internet, from the wire manufacturer. So here is an example of a data sheet that tells us everything we need to know to get started using this wire. So the first thing we'll look at is what type of current that it requires, and in this case it's DC electrode positive or reverse polarity. And then we'll look at the welding parameters. So we'll look at what size wire we're using. We're using an 045 wire. So we'll follow that over, and there's a whole list of different types of welding parameters to use, whether or not we're in position or out of position. And so we can see the voltage, we can see the amperage, and the wire feed speed. And then on the very end, we'll also see the correct contact tip to work distance, otherwise known as the electrical stick out. And this is a very important parameter that we'll talk more about here in just a few minutes. So like I said, I always like printing one of these out whenever I get started with a new wire, because it has a lot of great information that helps getting started easier. So now I'd like to talk about some of the common mistakes that I see welders doing when out in the field using the flux core arc welding process. So the first thing I see a lot of folks using the wrong torch angle. A lot of folks use the push angle like what's used when using the gas metal arc welding process. It's recommended to use a drag angle, or known as a lagging torch angle, when welding with the flux core process. This will prevent slag inclusions and also considerably increase the weld penetration. So let me show you an example of a dragging torch angle. So I've got a simple T-joint here, and so I want to show you the work angle and the torch angle. So this angle here is the work angle. This angle here is the torch angle, okay? So if I want to use a 2 to 15 degree drag angle, I'm going to put the torch at a 45 degree work angle, centered on the joint, and I'm going to drag it backwards 2 to 15 degrees. And when you weld, you're going to drag the puddle like this. And so that's a drag angle, which is what's recommended for flux core welding, because this will help prevent slag entrapment and also considerably increase the weld penetration. So like I said, the penetration is greatly impacted by which angle you use. A drag or a pull angle will provide increased penetration over a push angle. So look here at this picture that I have. As you can see here, the drag torch angle produced a fillet weld that had considerably more root penetration than did the push angle. So just keep that in mind when you're welding, the difference in a push and a pull torch angle. So another common mistake that I see is the incorrect electrical stick out being used. Now the electrical stick out, as you can see from this diagram, is the distance from the end of the contact tip to the workpiece. The recommended electrical stick out when using the flux core arc welding process is between 3/4 and 1 inch for most wires. In some cases, an 035 flux core wire may have a shorter electrical stick out, but for wires that are 045 size and larger, usually are between 3/4 and 1 inch. Now it's critical to use the correct electrical stick out, because this stick out helps preheat the wire before it gets in the puddle. And this helps burn off any drawing lubricants or moisture that's accumulated on the wire. If this isn't done, then porosity can occur. And the type of porosity that you're likely to see is elongated porosity, which is also known as piping or worm tracking. Now one way to ensure that you are using the appropriate electrical stick out is to use your contact tip and nozzle configuration, is to have your contact tip recessed. As you can see here, I got my contact tip recessed about 1/8 of an inch back into my nozzle. This will help protect the tip, but also make it easier to maintain that little bit longer electrical stick out of 3/4 to 1 inch. So here are a few examples of what piping porosity would look like. So not only is porosity caused by improper technique or improper parameters, it's also caused by base material contamination. And this is probably one of the most common causes of the porosity, is by welding over rusty or heavily mill-scaled material, also material that has oil or grease, paint markers. Any of these things can lead to porosity in the finished weld bead. See, porosity is caused by gas being trapped in the solidifying weld puddle. And so when you have gases, or when you have contamination on the weld plate or the base material, and you try to weld over it, these contaminants vaporize and become gases, and they're trying to escape out of that weld puddle, but they can't do it quick enough, and so what's left is a pore. And when the gas is trapped between the solidified weld metal and the slag system, then you get this piping porosity. And so it's really important to keep the material clean. A lot of times folks think that the flux core arc welding process is more forgiving and you can get away without cleaning the plate. And that's not necessarily the case. It is better than the gas metal arc welding process, but it's always best practice to clean the base material before you weld on it. So just keep these few tips in mind when you're using the flux core arc welding process. Next, I want to show you what a good sounding and good looking weld looks like when using the flux core arc welding process. So there's our finished weld bead. The slag should pop right off real easily. And there should not be any porosity or wormholes. It should be tied in real good on both sides. Looks like it is. And that's all there is to it. So during this training module, we discussed the flux core arc welding process. We talked about what the flux core arc welding process is. We discussed how to identify the difference between an in position and out of position flux core arc welding electrode. We also shared a few tips to help improve the quality of your flux core arc welding process, and we showed a simple T-joint using the flux core arc welding process. We sure hope you have found this information helpful, and if you have any questions, please don't hesitate to contact your local Holston Gases distributor. Thank you very much for watching.